So let's start, students. It is time. The puzzle is solved, and in many places, I guess it should also be there in your mixtures class. The answer is going to be option choice B. And in any such, so the simple logic goes out as, first all of it was orange. All of this was orange. You just need to look at one of them. So all of it was orange. Now, at the end of it, the same vessel, it's the same vessel, it's not B. This is A at start. This is A at start. This is vessel A itself, yeah, at end. Now, what is important? The only thing important is the level is still the same. So the level is still the same, but orange juice is less. The orange juice is less, right? Why? Because some orange juice would have gone to the other side. You know, there are two things. Orange juice will go, yeah, and will also come back. Orange juice will also come back. Part of it is back. Part of it, right? But I'm saying together what happens is, finally there's some orange juice here. Now this space is not vacant. The total is still the same. So if the total is still the same, what happens is this part gets filled in with the lime juice. This gets filled in with the lime juice. And so this part is what has gone over there. And this is same filled with lime juice. So this volume here, so yes, Anmughi, this is about liters. This liters here, this many liters of orange juice has gone to the other B, and that many liters of lime has been replaced. So it has to always be equal. So don't get involved into the details of it. Yeah, what is going, what is coming, and so on. You could even take simple numbers and try it. So moving ahead with today's class, yeah, good enough, interesting class. Mostly there's very little theory here. In fact, there's no topic called mixtures. If you look at it in maths, there's no topic called mixtures, student. Mixtures is just about ratio and mixing and proportions, right? So if I want to put a name to it in terms of maths, it is only going to be either weighted average, use of weighted average, or even use of weighted average, or I'll just say use of simple ratios. How do I use ratios effectively? Okay, so therefore there's nothing much to teach, and it's mostly about solving. So when two or more solutions are mixed, the liters of milk, it would be good for beginners, you know, to make a distinction between liters of milk versus liters versus proportion. Yeah, it's a good thought to, you know, keep your mind very clear. What is the given question asking, given data? Proportion is nothing but the milk to total. Proportion is a fraction, milk to total, and proportion will always be less than 1. Yeah, proportion can also be expressed as a percentage, right? Whereas liters is liters, what we all know, right? So liters of milk in the final solution, students, is going to just be the proportion into volume. This is solution 1, right? This is going to be from solution 1, solution number 1. Proportion into volume, this is going to be from solution number 2. There are many things that are mixed. So these many liters. So this is proportion, and this total become liters, right? This become liters, right? So on, you'll keep going on, and that's it. So this should be N last. Proportion from the nth solution, and that is your liters of milk. Same way, liters of water. You would only change milk proportion, you'll change to water. So you can find milk, you can find water. And mostly the question is going to ask you about milk to water, or sorry, the total solution also you should be able to match up. Volume 1, volume 2, volume 3, just add all the volumes, total volumes. So this capital V will refer to the total volumes. Get used to these notations. Yeah, it's a very nice one. You know, when I used to struggle, when I used to prepare 20 years back, right? Then this milk proportion, I used to take it as milk proportion, and I struggled big time, in my preparation and all. I used to take it as X by Y, or, I used to write X by T to denote total. Now you don't need two variables, students. Today I just use a MP, and that too, right? And MP is milk proportion. You don't need two variables. Whatever, you might get it in the end as 5 by 8. So what does this 5 by 8 mean? This is that X, this is that total. Right? As simple as that. So continuing, question asks you milk to water. Most probably question asks milk to water. If you work individually in milk and water, then you would have both numerator and denominator to be calculated. But rather than this, if we work on milk to total, the denominator gets very easy. The denominator is just summation of volumes. You can even work on water to total, right? The denominator will still be sum of all the volumes, V1, V2, V3, V4. The numerator will change to water liters, right? So I repeat, students, just in case, there are going to be students who are going to ask, can I not do this? Can I not do this? Any of this you can do, students. Any of these. All of these are substitutes for each other. You can work on milk, you can work on water. Milk total, water total, whatever you want. And you can easily move from one to the other, right? From any one to anything you can move, right? So I don't think so you should be thinking that this is different way of solving. Okay, so and if you look at these formats here now, again, let me just clear it. If you look at these formats, these are nothing but weighted average formats. The last two are weighted average formats. So remember, the volume of the solution acts as the weight. And you can either work with milk proportion or water, any one of them, right? So that is a very feeble link to weighted average. Feeble, why I say is, isn't it logical? Liters of milk over total liters is milk to total. So hopefully there's not much of an issue there, right? This is just a quick revision overview. Let's just say, don't why that overview is necessary is sometimes what happens, students, is we get so involved into the formula that we forget that that formula has a very simple explanation behind it. So that was that explanation. Start questions, students. There's nothing much that we can discuss. When two solutions are mixed, read what do you search for in a question. Now, those who are not good with quant, I find them having this difficulty. Search for while reading a question. You are reading a question. What do you keep a watch for? And what do you note down? Yeah, what you note down while you're reading is, okay, there are two vessels and they are mixed and I get a resultant. Yeah, this is identified as a resultant mostly, right? Or this. Okay, so the word resultant will talk. And there are only few things that I need to look for. First is, what is milk proportion in first? Okay, usually what will be given will be milk and water. So what will be given is milk and water usually. So if it is, let's say 3:2, you don't say 3 by 2. 3 by 2 is wrong, students. Yeah, milk proportion has to be less than 5. Okay, so it's 3 by 5. Okay, and always work on proportion or percentage. Yeah, don't work on milk to water. Okay, that is one thing. Repeat that same thing for the second solution. So you're looking at how much milk, how much water. Anything that tells me how much milk, how much water. In the first, in the second, and then what? Pay attention importantly. A resultant, yes, the same thing. But more importantly, other than how much milk, how much water, very good, Shivani, the ratio of volumes. And I'll again tell you, I'll be looking at the ratio itself. I'll not look at them individually. I'll look at the ratio of the volumes, right? That is enough for me. So even if the volumes are given in a very bad manner, like what do I mean by a bad manner? Let's say this is given as 36 liters and this is given to me as, let's say, what shall I say, 63 liters. right? Then what I'm going to do is I'm not going to work with 36 and 63 liters. I'll quickly take the ratio of it and I'll say, oh, the ratio is 4 is to 7, right? So I'll work in 4 and 7 itself. I'll just change it to 4 and 7 and I'll work with 4 and 7, right? So these are just the 4 things. What? Milk proportion, and resultant, and the ratio of volumes. The more clear you are in this, the more faster you can move to your workings, reading. Speed is directly dependent on how you can anticipate questions and so on, right? Both are given, milk proportion and volume. So what is that is, you know, everything is known here, known, this is asked, right? So obviously you are going to use weighted average, right? What is the other situation? All 3 boxes are known. What are those all 3 boxes? The volume is not known. This is known, right? And this is known, right? So what will you do? We'll do alligation and we'll get ratio of volumes, right? This is to be found, right? And then if there are 2 unknowns, remember this also I think so should be very clear. In this people, there are 2 unknowns instead of 1. Then there has to be 2 mixing and 2 equations. Okay, watch out for these also. So another 2 minutes gone in just introducing. Start. Pen, pencils all out. Take your notebooks out. Sit up upright. Don't watch it lying down on an iPad or on a phone, right? Get into your position, students. It's only problem solving. Very small topic. Doesn't deserve 1 full lecture. So start. 2 minutes. Shanmuki, check calculations. The others are getting different answers. Okay, Gitanji, it will be a nice session to revise, but I'm using the same PPT, same questions. I just checked; it was a good collection of questions. Doesn't need too much of addition. Yes. Yes. Then either that means all the others are wrong, is it? Okay, let the time elapse. This question that you're seeing on the screen, let time elapse. No. Oh, okay. I was about, so time is elapsed, student. Student, this question I was going to say is a decent exam level question, students. Okay. And you will get this, means exam level questions are very similar. So let me, in fact, let me face you on the camera and tell you, students, you should realize that in an exam, even a very normal question or just about average question seems to be far more tougher, because of all the accompanying pressures. Accompanying pressures of what, that it's an important one, you are tensed, you have already done 2 or 3 difficult sections before this, right? So please understand, even a simple question might suddenly seem to be a tough one. And hence, you will not get very, very tough questions. There are very tough questions, but out of the 34 questions, that would just count to maybe 4, 5, 6 questions. The rest of them are all about like this, a little bit of language, or you just go very fast and you'll make an error. The second thing that I wanted to talk about is, students, I know it, at least when online started, the test taking, studies started online, I found people hesitant to use pen, notebook. They used to sit and watch. Okay, playing a video, okay, let's watch the video. Let's keep playing. Students, don't do that, right? Even in a Facebook group, when you see a question, I'm very tempted to immediately read through the solution or read through the comments. You have to get into that mode of, today you'll have to live with that online world, right? So keep a pen or pencil, a question is put in front of you, start solving it. Ignore what I'm saying or anything. Yeah, that is all background noise then. Solve it. You need to do it. Oh, and yes, maybe time pressure or so on, you might not be able to do it in 2 minutes or so on. But that doesn't mean you just start watching the lecture. Shouldn't participate. Yeah, it's an important part. Because you will have to go in and take a test online. I know it takes a little effort to read on the screen and then solve on a paper, but you need to do that. Okay, so let's read it. The volume of a solution having milk and water in the ratio is 4:1. Now this is how much milk and water. So this is your first one, and I would quickly say milk proportion, students, right? 4/5, directly use in this. And this volume, whatever is there, this volume is, the word is here. Who is the subject of the sentence? The volume of the solution is increased by 50%. Okay, is increased by 50% by adding. Oh, so I add something to it. And what happens because of the adding? So now I'm just writing it linearly. Otherwise, I would have written it below. The resultant volume becomes 50% more. This volume, the final volume, this volume, final volume, is going to be 50% more. So if it is 50% more, I'll take this 2. 50% more will become 3. So this volume that we have, unknown volume, what I am mixing is 1, student. So the volume ratio is 2:1. Okay. And by adding a solution, having milk and water. Now, whenever you see a ratio, just ask yourself, does it refer to volume ratio? Does it refer to milk water? Right? So it would be clear. So this is going to be 1/3. Very rarely, right? So finish it off. You know the ratio, you know everything. This is asked. So I would go ahead and I'll do weighted average. Let's not be very innovative here. It's not needed. For the sake of creative solution, I can do some weird ways of getting to the same answer, but not needed. So a little calculation. Yeah, 4 2s are 8, 8 3s are 24, 24 plus 5. And what is this? 5 and 3 is 15, 15 3s are 45. So that is going to be 29/45. Never forget that you are always working. So the overall thought process will always be, student, milk and water will change to milk to total. You would do some calculation, you will get milk to total, and you will change it back to milk and water. Okay, this will always be the thought. So don't leave it, because just a glance what is asked, and you should be able to say, okay, 29, 30, and 16. Okay, that was a miss. I think so. But I'll tell you what, today I did not miss this. I saw this is increased by 50% and I did it. But I think so in the first class when I did this, the first time in December or January, even I think so I had missed this part, is increased by 50%. Okay, so it happens by a lot of them. They took the ratio as 2:3. Most probably, Shanmukhi, they took the volume ratio as 2:3. Okay, so you will find the same type. So the first level of question is always about just wordings being a little mixed up. But then, no, okay, this is a standard one. So I'm finishing it off to save water, right? To save time along with us. The ratio of salt and water in two different solutions, right? So this is obviously salt, water in two solutions. So this is your 3/7 is the first one. And I'll start writing. 5/11 is the second, right? Now, if it turns into alligation, I'll draw a box where the cursor is. If it's weighted average, I'll complete it. So I'll just leave some space and start writing. Now, the two solutions are mixed together. If the resulting solution, so this word resulting should say, oh, I'm going to the last one, is 18 liters of having salt and milk. So again, 4/9. It turned into an alligation. I wrote this off. And remember, yesterday we did this. Yesterday itself, right? Yeah. When alligation is with fractions, I do think it's an easy one to just rather than you work with fractions, which you can. It's the same logic. Just multiply with the LCM. So 7 gets cancelled. Nothing here. Very bad numbers. Very bad numbers. What is this? Correct, I am.
So there is 9, not 19.
Yeah, okay, yeah. So, okay, then it's better. 7 gets cancelled, 11 nines are 99 thrice. That is 297, right? 11 gets cancelled, 63, 5 times. 315, right? What cancel? 11, 77, 4 times. 280 and 28. If I'm not wrong, 308. So I do that part, 97 to this is going to be 11, 8 and 3, 11. And this is a 7. And this is the ratio of volumes. Remember, this is the ratio. Irrespective of whether you work on salt, yeah, these are what salt proportion, right? Or you work on water proportion. The ratio will always be of full volume. Yeah, always of total volume, not of salt or water. It is not of salt or water. Okay, irrespective of what you work on, right? Be comfortable. Yeah, those things. So obviously, since it's 18 liters, these are going to be actually 7 liters and 11 liters. That is what is asked. Find the volume in liters of the two different solutions. Okay, so as I told, nothing great that. It's just a repetition. Okay, all questions are not so easy. Okay, so questions start. There's a shorter method in this. Rather than do, I'm just giving you a hint. Rather than do 2 mixings, or rather 3 mixings, you can reduce it to 1 mixing. Go ahead, read it on your own and try the shorter way. I've given you a hint. 3 mixings can be reduced to just 1. It will take a little time, so no pressures of time. I'll give you 2.5 minutes comfortable. Okay, the time is just kept, to keep an idea of how fast time goes. When we say questions have to be solved in 30, 40, 50 seconds, it's all unrealistic, absolute unrealistic. Reading it, comprehending the question will take time. Volumes. Okay, you can. I'll just finish it the short, the longer way. LCM 15 and 6, 34, and this is 3 2 the 6 5 10 10 and 4 14. So the shortcut, we can equate volume of B. Yeah, yes. That is the idea. So the one single mixing is, why not mix all of this directly, to get to this. That is the idea, Shanmukhi, right? Don't get these intermediate ones into picture. Don't get them. So when you're mixing all of them, you are going to think of this as one box. Think of this as other box. You'll take them in what ratio? You're taking them in equal volumes. So try to get the volumes to be same. And quickly go to numbers. B should not be same. Yeah, what you need to do is the total volume of the left should be equal to volume of the right. So these volume will go in multiples of 3K. These volumes will go, what is this? This is in the ratio 1:3, right? B and C. Or this will go in multiples of 4N. 3K, this will go in multiples. I've already given you a hint for shortcut. Try that and get to the same answer. In the meantime, I'll just... Okay, let me explain. So let me explain. So a little thought, students, a little thought. Pay attention. When I know that there is fraction involved, right? In this question, there is a fraction involved. It might be, it's a very small point, but just in case if for anyone who has a good memory, you can use it. Because fractions are involved, I know fractions are going to be involved here, right? So I do the fractional weight. Okay, and I occasionally use that. 2/5 is milk proportion. And what is the weight? I take the weight as 1/3. Okay, what is the milk proportion in the second one? Half. And what is the weight? The weight is 2/3. Like this, what happens is I can do the calculation of fractions easier. Rather than doing 2/5 into 1 plus 1/2 into 2, what will this be? 2, is it? Okay, divide by 1 plus 3. Rather than doing it this way, I could just do it this way, the fraction. Oh, so the 2 and 2 will cancel out. So what is the LCM? The LCM is going to be 15. Right? 5 3s are 15. That's a 2 and a 5, 7/15. I get D as 7/15. Try doing that same thing here on your own, students. Try to get that.
सर C में आपने 1/4 लिखा है, वो 3/5 होगा ना?
ओके, हाँ ठीक, गुड. मैंने क्या कर दिया? अच्छा, मैंने ये रेशियो देख लिया, वॉल्यूम का रेशियो देख लिया. ठीक है. मिल्क एंड वाटर इज गोइंग टू बी व्हाट? इज गोइंग टू बी 3/5, right? And I'm mixing them in what ratio? 1 and 3. So try that part. Milk proportion half. The weight will be 1/4. 1 by 4. And this will be 3 by 5. The weight will be 3/4. Now, does anything cancel? No. So I'll take the LCM business here. This is 5 4s are 20. This is 8. Oh, that will be 8 into 5, 40. 40 as the LCM. 5 plus, what is this? 20 double, 18. 18 and 5, 23. And now what happens? Now look again, I'll just use something. For D and E, what are we doing? Are we doing equal volumes? Now, if it is equal volumes, it simply means arithmetic mean. So it means 7 by 15 plus 23 by 40 by 2. Equal volumes means just arithmetic mean, right? So if I take again the LCM this time is going to be what? 80, 120. 80 and 120, right? 120 by 2. I'll leave that 2 years. Something should cancel out. Let's see. And what else? 120 is 8, 56. 56. If I can't remember numbers, just note it down. 3 times this, 69. So much of calculations. 5 and 6, 6, 125. So the 5 will cancel out. 5 will cancel out. 525, 524. So that is 24, 25 by 48. And remember, this is what? Milk to total. The question will be asking milk to water. So milk is 25, water is going to be 23. Okay, you all got the answer very fast, students. You all got the answer pretty fast. I thought it took a lot of time. Right, I took a lot of time here, right? Okay, and now, now to be, I'm erasing this. You can do the calculations on your own. But if you actually look at it, what I did not like about it is I've done 3 times calculations. Once, twice, and then thrice. 3rd time here, right? That's a lot of work, student. That's a lot of work. So what happens? How do you manage the shortcut? Pay attention. In the shortcut, you directly mix the earlier ones and directly get the last. Do not find these intermediate ones. Chalo, you should get it. I find students not picking that up. It has been explained in the videos, right? When you are having intermediate parts, okay, intermediate parts. So everyone start. Yeah, you should be getting it, student. I've cleared the screen very well, right? So go ahead on your own. You think of this complete. The left one, complete one, and the right, this complete. Now, what does this is D? Don't get a new D into picture. This is not D, so this is not. What is D? D is just the first level. Yeah, don't get into the middle level. Oh, so you want equal volume of the left. Now, where is the volume of the left? Go ahead, tell me what is the volume. Does the volume go individually? Does it go 1, 2, 1, 1, 2, 1, 2, 1, 2? So tell me what is the total volume? Can I not say it is 3 multiple of 3? And what happens individually here? 1, 3, 1, 3. I hope you're getting it. 1 part of B, 3 parts of C. 1 part of B, 3 parts of C. So tell me what is the complete volume going to be? The complete volume will go in multiples of 4. And this I need to be equal. Equal volumes. Right? So why not just take 12 liters? Can I do this? Remember, it's just the ratio that matters, no? You can take 12 liters, 12 liters. So tell me if I have 12 liters, now break this 12 liters into A, B, and C. Oh, 3 parts is 12. This is going to be 4 liters. This is 8 liters. Have you got this? Break this 12 into B and C. Oh, what? 4 parts is 12, 3 times. So this is going to be 3 liters. And this is going to be 9 liters. Right? Now mix all of them. So what is this? A, 2 by 5. And I know it is still fraction. So let's see. How many liters of A? 4. Okay. Okay. I'll just leave this as 4. What about B? Oh, B is half. Okay. And half and how many liters? 8 and 3, 11 liters. Okay. 11 liters. And what is C? C is going to be 3 by 5. How many liters? 9 liters. Do you know the total is going to be 24? 12 and 12, 24. You could have, if you are very fast student, if there's only one, your mind is working at super speed, you could say 4 by 24, 1 by 6. Okay, into 11 by 24. The total is 24. Okay, 3 by 5 into 9 by 24. Keep reducing as you see. Oh, 3 threes are and 8. Okay, now what is the LCM? Let's see the LCM business. There's an 8, there's a 5, there's a 3. That's it. Rest, you're looking at primes. 5 is present in and 5. 6 is nothing but 2 and a 3. This is 2. This is 8 and a 3. Okay, so what is the LCM? The LCM is 8 into 3 into 5. Okay, 8 into 3 into 5. Let's see. What is this? 8, 5, 120. What is this? 30. 4. 4 twos are 8. 24 into 2. Okay, I need another 2. Okay, I need another 2. Get another 2 and make this 16. So it should not matter too much when you have. Okay, so this is going to be what? 8 threes are 24, 2s are 48. 5, 55. 8 fives are, so what is left? 3 twos are 6. 6 into 9. 6 into 9, 54. So 10, 15, 1 carryover, 10, 125 by, what was this? 240. Yeah, which is the same answer as earlier. If you multiply by 5, divide by 5, this will be 25 by 48. Okay, so calculation, will that be? Yes, that could be this much. This is not a difficult one. So some questions are heavy on thought, some questions are heavy on calculation. It won't be same if we divide by 24. It will be. Nahi, that would be, it has to be Siddhant. That would be just some error that you must be doing. I mean, no use of taking. You would know, without a 12 and 12, you can't get the volumes of A, B, and C.
No, sir. What I'm saying is that you reduce the you reduce back to the fraction, sir, by dividing by dividing the whole numerator by the 24. Like 1 by 6 you got, and then I think I don't remember 1 by 24. So want it to be the same, sir, because if I take out the 1 by 2 comment, then it is just like the arithmetic mean, the same thing. So no use of taking that 12 and 12. If we initially divide by 24, that's what I'm saying, sir.
Okay, you're saying in the calculation bit, you are saying, right?
Yeah. So yeah, calculation only.
Yeah, possibly, yes. Okay, so okay, read the question carefully. It is a little confusing. Okay, it's a little confusing, and it's also not relatively. It's not present in a lot of materials. Okay, so think and answer. It will take a little effort. It's not your run of the mill question. Okay. So fast. For those who are stuck or so on, try to just equate. Look, what is the first you need to realize there are three individual components, right? Constituents, whatever you call them. Three, and then you just try to write this if the equal percentage of ethanol and methanol. So you just sort of equate the ethanol to methanol. And remember, don't make it so this would be in fact, I don't know how you all did, but you all did it very fast. I thought this question is good thing. Don't do ethanol is 50%. This will be wrong. This will go wrong. But then I can equate them, right? This will be wrong, students. Okay, since it's time, I'll just solve it. In fact, you know what? You could have, instead of percentage is equal, you could have also written the volumes are equal. I've changed it to methanol and ethanol volumes are equal in the mixtures. Okay, and so what is ethanol? Ethanol is going to be just 3/5 of that unknown, because ethanol is not coming from anywhere else. And what about methanol? Methanol here is 2/5 of that unknown V plus, what is it from here? 1/5 of 6 liters. And what is coming from here? 7/10 of 4 liters. You know, it could be very shortened. It could be very, very shortened. Is going to just be, does something cancel? Very small things cancel, but it helps us. So let me just do that. Okay, here 6, 7 2s are 14, 20 by 5. Okay, there's a 5, yeah. So sorry, there's a 1 by 5. 20 by 5, which is going to be 4, so V is 20. Think a little bit of shorts, yeah. I've used a little bit of shortcut. If percentages are equal, that also suggests that the volumes are equal. And how do you change to percentage? You will just be dividing by something. Na? So both sides, that total will cancel out. You could even have thought it that way, right? No use actually writing them and so on. So I do think this is a little comfortable way you can do. It also opens your mind to, you know, 3 parts could be there. It need not always be just 2 parts. And remember, when there are 3 parts, no students, mostly the question is going to be an easy one, because some, like ethanol here, is not present everywhere. In fact, I could have probably given you propanol also here, right? Then that is not present in the first one. So these are small thoughts. This is just when there are 3 parts, most of the time, the one of the solution might not have one of the part. That is what I'm trying to tell, right? So again, student, if there is a question mark or if you're not sure or so on, please stop me by putting a question Q or a question mark in the chat box, or else I'll just keep proceeding. There are, okay. This question is not, I don't think so it's same as your exercise. This question does take one by surprise, so read it carefully. Okay, let's look at Nikhil's message first. Nikhil, बहुत ज़्यादा type मत करो, you know, it will save time. Okay, I did by getting 4 liters of methanol from jug 2 and jug 3. Okay, yeah, but then how are you okay, from methanol, but if you got the answer, it would just mean similar. Yeah, if you got the answer and it's not a doubt, then it would just mean similar. You might just have written it a little differently. You have to get methanol from the first one also, but Nikhil, first one has methanol in it. Okay, read this question carefully. Brass. So there's copper, zinc, and there's copper, zinc, tin again. Yeah, so think copper, zinc, tin, 3 parts. One of the mixture may not have something. Be a little careful. If you haven't started, then you might see this. Okay, so think now. See this and then think. If you haven't started it, that is. Think what is it that you'll work on? Like as in milk, water, like that. What will you work on? Can you work on? Good. But a fewer answers in this have come. So Siddhan, Gitanchi, Shanmukhi have done. So still there's some time. So try that. So for example, Magnus Carlsen, yeah, if you start actually working on copper and zinc, so if I take copper, I have an unknown copper. I have copper that I don't know. Copper. Okay, I know this is 80% copper, 80% copper. And I know the result. The result is also 74% copper, right? But then if I look at the unknowns, I don't know this. And then if I don't know this, it's fine, but I don't even know the volume. So after some time, you'll realize, oh, fuse mass, how much, what is the volume of this? What is volume of one, volume of two? This is also unknown. So there are a couple of unknown things here. So will not be, so I don't know. So this is also unknown. Weights are also not known, right? So weights are also, so maybe that copper and zinc will not help. Yeah. So I'll still give you some time. Think copper and zinc, but what should you notice? So what was the last question trying to tell you? When there are three parts to it, brass is an alloy of copper and zinc. That's it. So what you need to know is, this is unknown, but do you know the tin part here? This is known. What is tin known? Right? Yeah. And now you know this is 0%. Go ahead. So from here, what can you work? Yeah, go ahead now. Finish it, Shivani and others. Shivam. So using tin and tin, now I know 3. So what can I get from that? From there, I can get that unknown. Yeah. Good, Ankit. Nice. So just a few more answers if, yeah, just a few. Good, Rajat. So when there are three, something not being present, helps. Something not being present helps you. Okay. So I'm giving you one more way rather than, it's not a way, students. Yeah, I'm just leading on to the next topic. So pay attention. You could obviously have done this, but I don't think so. This is a very good way to do it. Okay. So remember this 3:5 is the ratio of volumes. Okay. I would not be happy with this. Okay, I would not be happy with this. Seriously, I would say, what, you all are doing a lot of calculations, right? So why I would not be happy, not because of the extra 10-15 seconds taken. I've always said you cannot be, worried about the 10-15 seconds. Your exam will probably not go well, not because of the 10-15 seconds that you took extra, but probably of other factors. Spending 2-3 minutes in a question which you should have just left, panicking, a little worried, or so on, or going in order, not looking at all the questions. These are things that are going to be far more important than just those 10-15 seconds. But so what I'm not very happy is with the analysis. So pay attention, a nice thought coming up. Yeah, for this. When something, new words, when something is not present, if something is not present, like for example, tin, then equate its volume. Equate its volume. This is if you want it in theory part, what we are talking about, work on no change component. We have done this even in ratio proportions. Yeah, when material cost goes up but labor cost remains constant, we say no change component. So what is that no change component? 10. So instead of this, what I would have recommended is, what is 10 in this? 16% of V2 is equal to result 10% of resultant. Now use variables interestingly. So what happens from here? I straight get V2 by resultant volume is percent cancels out 5/8. So remember, what is this V2? V2 is 5. And what is V1? V1 is 3. V1 is 3, students. Hope you got this. Now, again, as I told you, it's a question of just 5-10 seconds. But then I think this is conceptually, this is a better way. If you don't want to work with not present thing rather than given values, no, it is not possible. In this question, Magnus, in this question, you can only solve it because tin is not present here. Because tin is not present, that is the only reason I can solve this question. If this was not, if had this been anything other than 0, I would have not been able to solve it. Okay, so I hope you get this. So now just to finish off the question, once you have, now go ahead and once you know the volume, just go ahead and get the copper, right? Get the copper and so on, whatever it is, right? So what did we want? So we got 5:3. Now what do I do? I'll probably do weighted average only. I prefer weighted average over this. So the unknown, copper proportion unknown. What is the volume? 3. What is copper here? 80 and 5. And look here, I don't like to write the denominator. It's a habit that I've picked up after a lot of practice, right? What is this? This is 74 into 8. I write it this way, and I get a lot of mind peace. I think I don't like the denominator. The denominator 8, I have just moved it to the other side. And then it somehow tells me, okay, I'm pretty fast. Okay, so what is this? 80. क्या हो जाएगा यहाँ पर? It's 560 and 34, 592. And what is this? 400. So when I subtract it, I'll be left with a 192. When I divide by 3 6 are 18, 3 4 64. Now if copper is 64%, you know zinc has to be 36. Why? Because the total has to be 100. Okay, so again, probably if you have done this question fast enough, you would find this a little waste of time. So okay, now these are questions that have been asked as doubts. Okay, lots of people ask doubts of mixtures. Lots of people, yeah. So I've just picked up the one better one, and then there's an alloy of silver and copper. Certain weight of this alloy is mixed with 15 kg of pure silver. Okay, and listen, that word but this is very rarely used, but if it is used, you should immediately be able to this, right? So there's one mixing. The new alloy contains 90%. So when you read there's an alloy of silver and copper, you should here itself start how much silver, how much copper. Silver, copper, right? You do not know that. Silver, copper, what, right? So you should tell yourself, I don't know. Now a certain weight, so I don't even know the weights. Let me just call them volumes. I don't even know. So there's a lot of unknowns right in the first line itself. 15 kg of sour milk gives me 90% silver. If that same alloy is mixed with 10 kgs of 90% silver, then the C is having 84% silver. So you should be quick. So look at the heading if you want to just get an idea of what we are discussing, right? If you have seen, and go ahead, a little 2 minutes. Yeah, Gitanji, I think so. You had asked this question also. Okay, so again, it is taking a time, students. Yeah, it is taking a time. And I'm not too sure how. So again, my thought here is going to be, student, mixture is again a type of topic where out of 100 questions, maybe one question is undoable. Most of the others are going to be pretty standard ones that can be done, right? So take that as a challenge kind of a thing. The mixture question, I should be able to manage it always, right? So I'll still give you a little more time. Yeah, think about it. I'm not too sure. So if you are getting stuck by trying something new, then go back to your things, look at the question and everything. Okay, 90% silver, 90% pure silver is 100% silver, 84%, find percentage of silver. Yeah, it's not something that takes a lot of effort to find. So work on silver percentage, and then go ahead, first mixing. Unknown, yeah, unknown percentage. What volume? Unknown. Keep doing. No, what is the problem? And mixed with what? Mixed with, where is it mixed with? 15 kgs of pure silver. 15 kgs of pure silver. So I'm just giving you a start here. You should be able to do. And what? 15 kgs. Remember, don't write the denominator, please. Write the resultant over here and then put whatever you want. What? The new alloy contains 90% silver. 90% of what? Put that V plus 15. You'll realize I don't need a V1, V2. So I don't think this is a tough one, students. Yeah, honestly, right? And the percentage cancels everywhere. There are two unknowns. Two mixing, two unknowns means two mixing. Is there another mixing? Yes. If alloy A, same thing, same volume, is mixed with 90%. Oh, 90%. Okay, of what? 10 kgs just. Then what do I get? Then I get 84%. 84%. Or what will it be? V plus 10. Question is asking us to find X. It might take a little time, but you should be able to handle it, right? In fact, I tried getting a shortcut to this question. I have not been able to. Yeah, it's not a very easy. So I've left it at some point. There would be one or two questions where, you know, the equations, you'll have to deal with equations. Little bit, yes. So I'll come to that. So my point, I will come to that, Siddhant, copper. Yeah. So my thought was that when I said if you're trying something new and you're not being able to, because the answers are relatively few, students, again. I hope you all are not sitting and watching it and so on. And is it very difficult to this? I don't think so. It's a very difficult one. You know what, students here? You know what? Try first subtracting. Do you know that X will cancel out? First, the percentage goes away. So I'm subtracting and I'm finishing. Let's see how much time. 1,500 minus 900, 600. You know, 90V minus 84V. You should be able to do that on your own. 90V and 84V. So that is going to be a 6V. Okay, a 6V. I'll tell you with copper. That is why I did not start over there. Let's see. 6V. Shall I continue? Okay. And 90 into 15, 84 into 10. Or 19 into 5, 1350. 84 into 10, 840. Do the subtraction. That is 510. Now here onwards, hands free. You have done these many jotting downs. It's okay. So for final V direct. Take that goes out over there. Oh, V is 15. Oh, now put V is 15 and finish off. Get an X. Oh, 15. Oh, 15 cancels out. 15 cancels out. And 15 cancels this with a 6. 15, 6 are 19. And this is what? 30. 15 plus 15. So finish it. 31, 180 minus 180. So it wouldn't be very bad. And okay, so it wouldn't be very bad. Now, having done this, what I was worried, you know, is, student, I just ended up saying in the previous one, yeah, in the previous one, pay attention. Yeah, it's a little tricky one. Pay attention. In the previous one, I ended up saying, listen, it should strike you. Pure silver, copper is not present. Copper is not present. Okay, oh, this is the no change component. Let me work in copper. That thought should have come. It should have come. And it came to my mind also, and I started writing. Oh, but tell me, okay, the question is asking silver, but let me work on copper. Oh, I don't know the percentage of copper. The problem is I don't even know the volume. and tell me in the new one, do I know copper is 10%? Yes, copper is 10%, but what is the volume? I still don't know. Or what is it? It is going to be V plus 15. Okay, so it doesn't immediately give me a result. Are you all with me? Now, what is X? Now, X is copper percentage. You want me? I'll change it to a Y. In fact, let me change that. Or else will just struggle with it. Y% of copper into some volume. It is mixed with pure silver. So no copper comes in. Okay, and what do I get? I get 10% copper. 10% into the volume is going to be V plus 15 kgs. Yeah, this 15. And now if you write the second one, you'll notice that, okay, so you should have got that, Shanmukhi, with copper also. Same with Aman and everyone, you should have got it, but you'll have realized that it does not add any help. So again, it's Y% of V in the first plus. Now let's see, 10 kgs of 90% silver. So can I say, oh, copper is going to be 10% of 10 kgs, and this will result in 84% silver, would mean 16% of V plus 10. So essentially, if you see, it did not help me as much, but then you can definitely do it.
Sir? So why did you take 10% in the second statement? It did mention the 10% is copper, right?
Okay.
I was not sure about that only. That is why I couldn't do it.
Okay. Yeah, okay. I'll allow that. It's a valid concern, because how do I know that it doesn't have, other than copper, it doesn't have some other element? Yeah. Yeah. So probably I am having that, limited. I just assume that since most questions have milk and water, here it's silver and copper. But yes, what you say has a logic, complete logic. Okay. Rest of it. Can I work on the rest of it? Let's see. Rest of it. Yeah, I still think that the answer you'll get it here, but what you say makes pure sense. Yeah, I just, yeah, it's perfectly fine. Okay, so shall we go ahead then? So student, to mixing two values, please don't hesitate. Sometimes you would be needing two equations, two variables, a little algebraic solution. It does come in. Okay, so okay, a good question. This is about, removing and interchanging, and the moment this comes in. So the first sentence is very easy. The first sentence is very easy. Jug A has 20 liters having 40% milk. Okay, in fact, all the values are also very easy. I never asked you to focus on the values now, but think about it. 40% of this 8 liters, all values are easy. Jug B has 30. Oh, so you have V1, you have V2, you have milk 1, milk 2. Now, what is this is, X liters are taken out from each of the jugs and then poured into the other jug. Now, this is what makes a few questions very scary. Okay, and it is from experience and so on that I'm saying. Again, you should also be able to manage. Now, there are two ways here. Yeah, so I'll just finish this, Rishuvi, and see if it gets answered, what you're asking, and then I'll come back to you. Student, there are two ways. Ask yourself, is it, I hope you're listening, right? Is it step one, take X liters from A, put in B. Okay, and then step 2, take X liters from B and put it in A. Versus, now is this different from this? Take X liters from A, and I'm just repeating, and X liters from B. So take them out first. Okay, and then interchange, put into the other. Is the two different? Put into the other. So I hope you all realize, and then please spend some time thinking what is happening here. You want it to be a little more visual. I'll draw some pictures and so on. So in the first one, what do? I remove from the first and I put it into the second and I mix. Then from the second, I remove. And both type of these questions are asked. Okay. So, and what is happening in the second? Think in the second, you have two hands. So you remove from here and you remove from the second one also, right? So you have both removed you have, and then you interchange it, right? So please appreciate the difference, students. It is an important point. And in this question, what is happening is the second one is happening. It might be ambiguous. So I am, explaining it to you. If I give this question in an exam, I'll write a little more details. So this question. Yeah, Rishovi, now let me see if what was your thought.
So I was asking about the previous question. Actually, just wanted to ask, like, they haven't mentioned that when the alloy is made, there are some impurities added. And why can't we take 10% and 90%? I mean, they have not added it in the question, right?
Yeah. So yes. I'm answering it. Yeah, I'm answering. So what I'm saying is, both what you are saying and Shanmukhi are saying is right. The only thing is, what I'll say is, because I do not know, I can't assume it either ways. Yeah. So what you are arguing is, it's not mentioned. So it must be only copper and silver. There might not be anything else. It may be, but my only thing is, it is possible. I do not know it. And therefore, I would just say, and you know what? I even while answering to Shanmukhi, what I said is, I still think this will give me my answer. But yes, there is a bit of a logic in saying, if I say a solution has 20% silver, that sentence, I don't want to go back to that slide, but it just says is mixed with 10 kgs of 90% silver. Okay, let me in fact go back. So if you look at the first one here, Rishuvi, it's very mentioned that there's an alloy of silver and copper. The first one, it is specified. Hand is all gone sweaty. The first one, it is all specified that it's silver and copper, right? But if I look at this, it is mixed with 10 kgs of silver alloy. Here it is not mentioned that the other part is copper or anything, right? So it may or may not be. So you are inclined towards, since it's not there, it will not be there. Since nothing is written, there is only copper and silver. Shanmukhi is saying, since nothing is written, it may be anything. I honestly I cannot take any side in this. I'll just say it is open for interpretation. So I will just be safer side, right? So on the safer side, I'll say, let me work on the silver part. But yes, right? So that's the best that I can respond there, right? Because now there are ambiguities in the language of the question. Everyone is not picture perfect in, thinking. People give nice interpretations to written words. So let's just leave it there. This is a nice question, coming back to this question, right? So here in mixing, yes. No, Shanmukhi, in the first puzzle that I said, it did not matter in which order you mixed or so on.
Sir, in that puzzle also you first put in.
Yeah, I got your meaning.
Yeah, that is.
So this question is not same like that.
No, not this question, sir. You gave two explanations. No, that is, yeah. Okay, sir.
Yes. So just to get everyone onto board what we just said, if you remember the first puzzle we had, from orange juice, I took something and I put it into the lime juice. And then after putting it in, I removed from the lime juice and got it back to the orange juice jug, right? So that is how I explained the part 1, possibility number 1. And possibility number 2 is what is written in this question. The part that I said, use both the hands, remove one from each jug and then interchange. Chalo, go ahead. Nice question, student, this is. This is a nice question. Go ahead. It's a pretty good question. So your time starts. Few answers have come, so I'll just give you a little more minute. This is a nice question. Try. Okay, student. Maybe sometimes the explanation goes long, so I'm just starting off. Now, what you should realize is, think what the mixing is happening. You have jug A. So jug A has what? 40% mixing, 40% milk, and there's 20 liters. Jug B. Thinking you should get this question, right? Either ways, even the longer way is a good way to practice, because you will 30 x liters are taken out. So remember, there's this x liters here. It will be same 40% milk. Okay, it is just x. So what will be left will 20 minus x. So just think that I've dipped my hand and I've removed it. Yeah, I've just taken it off. At the same time, I'll remove from here also x liters. So what will remain will be 30 minus x. And what I remove is going to be 75% itself, student, right? Nothing changes when we remove a solution. Now the mixing is happening is this is mixed here, okay, and this is mixed here. So you should have got that idea of there are two mixing that are happening, and what it says, the percentage of milk in the two jugs are equal. So this long way also there is a value. So tell me the mixing in this first one. First one, what is the ratio of mixing? Look at this. Can I say it is 40%? I'll just leave all percentages. into weight of x plus 75 into 30 minus x. Okay, and divided by x plus 30 minus x. Okay, I'll just put that down also. Though you should have written 30 itself here. Right? So this is going to happen here, students. And what happens in the second mixing, right? I'll start from this left part. It is still 40, but its weight is 20 minus x. Okay, and what is this part? So this thought, you know, sometimes I think is an important one for you to hold in your minds. The possibility of volume, 40, 75, and these are equal. These two are equal. That is what is given to us. Okay, and if you're fast students, you should have realized that this is just 30, this is 20. So you should first reduce and then cross multiply. Okay, so I'm multiplying, cross multiplying with a 2. So that's going to be an 80x, opening out the brackets. Okay, 150 into 30, 450, 4,500. Then what? 2 times, now minus 150x. You could have even reduced the numerators by 5. By 5 or what? Yeah, only 5. Chalo, let's leave it now. 75 2s are 150x. Now cross multiplied, I have cross multiplied. And this side what? 3. So 4 2s are 8, 8 3s are 24, 2,400 minus 120x. Okay, and what? 3 times plus 225x. Is this how most of you have done? Those who got that 12. A lot of you have got 12. Okay, Chanaki, you have that was fast. I just want to see how many of us noticed that part. Anyone, Aman or around, if you're around, who have done this question? So Vivek, Rajat, Aman. Oh, so again, very few answers have come in this question. Student, this part, no, you would need to do that effort, right? There's not much shortcut that I can tell you in this sort of working. Yeah. ठीक है अमन, तो ये 4,500 or 2,400 है, so the leftover will be what? 20 would make it 21. 2,100, this is going to be a minus 70, and what will be here? This will be a plus 105, is it? Okay, so that will become a 175x, right? And then you'll cancel it with a 25. Cancel it directly with a 25, okay? 25 sevens are. And here what do you do? 21 into 100. That 100 cancels with a 4. 7 3s are, and that's 12. So x is 12. Students, I don't think there is a lot of, I don't think that you should avoid this. So everyone, at least in the initial, when you do this, you should be able to manage this. 40 into x and the rest of it. 75 into the rest of it. 40 into the rest of the solution, 75 into x. You should be able to manage this, students. Yeah. So I would again ask you, and don't take these small suggestions very lightly. Do it yourself. Don't try to read through it again. Right now, coming. Okay, I'm giving the shortcut in a little unusual way so that you realize this. Okay, pay attention, students. Yeah, important concepts. The moment I write something like this important, I hope that you will pay more attention. Student, it's seriously. Okay, you might not appreciate this, pay attention, but I'll help you learn this. Some liters of 40% solution is mixed with 75% solution. The resultant is, let's say, some x% solution. Pay attention. Yeah, try to pay attention with me. 40% mixed with 75%, the resultant is x%. Another liters of 40%, again 40%, is again mixed with 75%, and the resultant is again x%. Let's say all are milk. So I hope you all realize that in both the mixing, 40% is mixed with 75% and I get some X%. I don't know what, but it's X. And there's another mixing. In that also 40% is mixed with 75% and I get the X% itself. This is what should draw your attention. So go ahead, those who are not very clear of what I'm talking, go ahead. What does this tell you? What does this tell you about this? Okay, left and right, both. Isn't it like this? When I mix 40 and 75, will I always get X%? You know, the beginners might say, what is the difference? This left is same as right one. Left is same as right one. Okay, so one way, Amay, you could say is the volumes are equal. So good thought, Amay, right? One way is both of them are identical, right? And so this is identical to this. So they are same. So you are saying V1 is same as V3. V2 is same as V4. And I tell you, no, they are not. They are not. I give you an answer, no, they are not. Now tell me if they are not, then how? If they are not equal, Amay. One is they're identical. I'm saying they're not identical, they're different. Then how is it possible? Then how is it possible? What is going to be same out over there? Think it's not a difficult one. And yeah, it's not a difficult one. Yes, Shubham, right? And let me clear this a bit. And let me ask you from yesterday, I had this thought of, you know, girls, the average age of girls was 18 years. The average age of boys, right? And is 20 years. Pay attention to this. And the average age of boys and girls was 19.2 years. If you remember, right, this was that. And the boys and girls, I knew that they were in the ratio, oh, they were 20 girls and 40 boys. Something like this, yeah. And then I compared this with, oh, this is same 18 years, this is 20 years, and the boys and girls were not 20 and 40, were 200 and 400, if you remember. And what did I get the age? I again got 19.2 years. So remember, the girls are not equal in the two situations. Yeah, I got this mixed in the same ratio, but the ratio was same. The ratio is same. I hope you got this idea, right? And if this is true, you know, yeah. So, and it's a nice point, and it's a difficult thing for us to realize. So remember, this is same question again I'm doing, the one that we did. So are you mixing 40 liters of, are you mixing 40% solution with 75% solution and to result in some X%? Are you mixing 40 and 75 again to result in X%? The percentage of milk in both are equal. So the ratio of mixture. So this is an amazing shortcut, students. So listen, I'm going to take it out this way. Taken out is what? X is mixed in the other leftover. Others leftover. Right? What is the other leftover? 30 minus X. And what do you take out? This is 40% well. And what do you take out from here? 40% one is going to be 20 minus X. And what is the other one? X. So this is the 40% mixture. This is the 75%. So these two are equal. Thankfully, you know what? This doesn't become a quadratic. It's a very comfortable one. 600 minus 50x plus x square. X square cancels out and x is equal to 12. Very nice shortcut, very good thing. Please be careful of the ratio, numerator, denominator. Again, it's very easy in my mind when I write this. Okay, when I write this, because I know that visual way. What is that visual way? This is mixed with this, this is mixed with this. So this side is 40%, this side is 75%. This is x is mixed with what? 30 minus x. Okay, and what is the 40% part? 40% part is 20 minus x is mixed with x. Hope you get that. So whichever way. Just remember, keep the same sides, numerator, denominator same. Student, it's nice. It has been asked in CAT. It has been asked in CAT. It has not been asked in other exams as much. So it stands a good chance of you seeing them. Okay. Replacing part of a solution. Now, people find this question tough. Yeah, I think, and you know, these are your small personal likings. I like these questions a lot. What is replacing part? Replacing part is you remove and you mix, remove and add. So this is a mix of two parts. You remove and then you add. And remember, the shortcut that I'm doing here is just that you add with a pure part. Such questions, when people ask me on Facebook and so on, I really like it. I say, wow, another chance for me to check. All these questions are going to be super easy. I'm not saying they'll be super easy at the start, but if you've got the logic of it, it will super easy. So how do I think about it? Pay attention. I first work on the part that is not replaced. I can work on both proportion and liters, but I will work only on proportion. Yeah, I have sort of, you know, I have built skill in this. I have built skill in this. So if liters is asked, I will still work on proportion, and later on I'll go to the liters. Okay. Now I cannot probably explain everything here, but I can definitely highlight what I'm doing. I'll break the replacing part into remove. When I remove, volume changes. Volume, in fact, I'll say is reduces. Reduces. But proportion does not change. Proportion does not change. Right? I'm going to work on proportion. So remove, I'll just say volume has changed. Proportion has not. When you add, the volume increases. The volume increases and the proportion reduces. Why? Because I'm working on the part that is not replaced. Something else is coming in. So proportion will replace. The proportion changes inversely with volume. Since volume always increases when you're adding something, therefore the proportion will always decrease. And I will just think that the multiplying factor is less than 1. I'll not take help of that V1, V2 or so on. Yeah, it's a very comfortable one, right? And I did not want maths to come in, so I've kept it verbal like this here. So what are you going to do? I am going to run a script, run a film of volume in my mind. Okay. Volume, pay attention. So I'm giving you random things. Okay, I'm giving you random things. I remove 20 liters. Okay, and add 25 liters. Okay, next I remove 15 liters. Okay, and I add 10 liters. Right, something like this, anything can happen. So I'm going to run with a big volume. Listen, so I would, let's say at start there's 100. Now you might question this. I'm just going ahead to explain, students, nothing more. Okay, at start it's 100. What happened? Remove 20, became 80. Okay, proportion same. I'll run a thing of proportion. Proportion, whatever is X percentage is same percentage, no change. Why? Because it is removed. Remove does not change. Oh, add 25 liters. Oh, add 25 liters. Does it become 105? Oh, if it becomes 105, what will you multiply? Less than 1. 80 by 105. Done over. You remove 15 liters. Oh, you remove 15 liters. 90 liters. Oh, nothing happens to this. This is still X into 80 by 105. Nothing happens. Volume has changed. I've already done that. Okay, you remove, only the volume will reduce. Oh, you add, what did you add? 10 liters. Oh, 10 liters added, it became 100. Oh, another multiplying factor of proportion reduces. But remember, all this is done on what? Is done on the no change part. So add 10 liters of water. Add 10 liters of water. So this will be milk. When you're adding water, milk proportion will reduce. You add water, milk proportion will reduce. And these things will not change at all. Nothing here changes today. You can be very fast. Yeah, Shanmaki.
Sir, sir, why do we always work on a single thing, like either of water or milk? Can we do even when once water replaced with water and the next time it is replaced with milk?
You will have to switch in between. So,
oh yeah, okay. Okay, sir. Yes.
Yeah, so what I'm saying is, let's say here, sorry, at this stage, in the first time I'm adding water, my pencil, yeah, I'm adding water. So what am I working on? Milk percentage. The second time I'm adding milk, what I'll do is here I'll switch over from milk to water. I'll go. So if you know milk percentage, do you know water percentage? Yes, the complement. And then I'll go ahead. Right, okay. And there's one more thing that I haven't taught here till now ever, right? You can even do the same process when you're adding something which is a mixture, right? I haven't taught you that, but that's also very easy, okay? So let's go ahead. Let's see if we can reach till that point. It's easy, students, and just break it. Don't go with a mindset, break it. Replay, remove, add, remove, remove, add, remove. Order can be anything. Don't get fixated. Yeah, work on individual. So not much time. Yeah, fast, yeah. Start doing on your own also. I'll just read it. I'll give you a moment. Yeah, whatever takes. From 100 liters, milk and water is in the ratio 7:11. 10 liters is removed, replaced with milk. Watch out. So I don't want you to do an error. Yeah, replaced with milk. 20 liters is removed, replaced with 30 liters of milk. Okay, thankfully. Find the liters. So everything is liters. Chuck it. You work on proportion. Go ahead. This is milk is being added. So what will you work on? So start working. Start working. What was water? Don't make errors. Right? Okay. So now, I hope you all would have given that up. Yeah. Now, start doing volume. Work on the volume part for 100 liters. It's an easy one. Finish it off. Just 30, 40, 50 seconds. Good, Jayesh. Good. Kumar, Nikhil, Urja, Parmeet. Good, Kumar. Right. So, Jayesh, so let's wind it because there can be some nice questions in this later. So what has happened? 100 has become 90. Just think, will a factor come in? No. Only when it increases. 90 has become 110. Yes, 9 by 11. Okay, 110 has become 90 back. 20 is removed. Removed, don't do anything. Just worry about when you add. When you add 30 or 120, you are adding. So this will become a factor. Adding will be a factor. These are those factors. So what is it? 9 by 12. You should have written 3 by 4 directly. So 9 2s are 11. 11 cancels. 2 is then 3 by 8. Now, what do you do with this 3 by 8? Yeah, this is a little tricky. This is what? This is water to total. Remember, you were working on water. And you know, from water to total, go to milk to total. Don't find water. Go to proportion only. Milk to total. And milk to total, you will, the liters. How do you get into liters? Now, these are small bits, right? You should know. The total, remember, at the end is 120 liters. Be careful at the end. Yeah, it's not 100 liters. because everything is different here, right? So 8 into 15, 1575. There's very little that I can make it a difficulty here, right? So you know what now? Now pay attention. What happens here is, a key thing that helps you is, remember I took the volume as 100 and then I said 90 and then 110. Because you know all this, it becomes very easy because you know this. So how do I make it a little more tough? I don't give you a start. I don't give you a start. Okay, that is how things will change, right? And you'll have to go in variables then. So if you look at the anatomy of the question also, a vessel contains milk and water in 3:2. Sorry, 3:2. So I know the start. The volume of the contents is increased by 50%. Oh, but then here a percentage has come. So I don't know what it is. I don't know what it is. But do I know I have added? And remember, it's directly increased. Increase means added. And does it become 50%? So what I would prefer doing it is 2V has become 3V. So even if I don't know, can I manage it? Yeah, you should be able to, student. Percentage is as good as a ratio. Now you needed a ratio. You have a ratio by adding water. And from this it is. So I've given you a start. Oh, then a 15 liters is withdrawn. Okay, I've given you a decent start. Okay, go ahead. Okay, this will qualify as a good question, right? As in a good question, not the highest level of difficulty, but yes, it would separate out those who have just done a formula and those who know what you're doing. So go ahead, complete it on your own. Last step, may people write the wrong answer. Yeah, just be a little careful. Okay. Mixture questions, all in all, you get one every alternate year you get. But now that mixer question could either be just about the earlier part, that is mixing two solutions, or it could be removing, replacing. So aren't the most popular, just about average importance. Okay, so I'm just completing this. Now, I hope you all realize that one is a percentage and one is a liters. And this liter is what creates a problem. Percentage is no problem, students, right? And this is what I just said. So probably, but then, so 50% increase. So I'll still go ahead now that I had started it that way. So 2 volume increases to 3 volume because you're adding. And since you're adding, you'll have to. So what am I working on? Milk. 3/5. And I'm adding, so a factor will come in. And that factor, remember, will always be less than 1. You do not have to waste your memory power or any intellectual power here. It should directly be less than 1. Now you, from this resultant, 15 liters is withdrawn. So now you're removing. So 3V minus 15. Now if you want to go this way, then you will go this way. And it is replaced with water. Okay, so now this word replace suggests that it is back to 3V. It is replaced. Yeah, now this is something that you would have to take it in the spirit of the question, because if you do not know, right? Nothing is written. How many liters means it's back to the original. So since you are adding, you will again have a ratio. Now you would not know which one is big, which one is small. No, but you know this is less. Oh, so this is going to be less. So this will be 3V minus 15 by 3V. Or just think, yeah, the less will always be the first one. It's V1 by V2. Before adding divided by after adding. And do I know this final ratio is going to be 3 by 10? Don't miss it out and say 7. Yeah, those errors will happen. So big deal and so on. This you could have a little faster way for here. Okay, you could have a little faster way, but I'll not push you. Okay, this is 2 by 5. 2 will go there. No. 5 will cancel this with this 2, so this side is nothing but 3 by 4. Remember, I've given you a shorter way than cross multiplying here. Oh, the ratio is 3 and 4, and do you see the variable is same, 3V. So can I say the difference is 15? The difference is 15. Yeah, I hope you all are with me. What difference? The numerator and denominator. The difference is 15. So the difference here should be 15. So this is going to be 45. This is going to be 60. So 3V is 60. You have got it. V is 20. Remember, original answer is 2V. Yeah, 40. So I'll not spend time here, because let me see if I can just, try and save your time and do some nice question there. So again, hopefully there's no doubt. So I guess the next is the last question. Yeah, this is a tricky question. It is like an exam question. Okay, it's on the lines of a puzzle, but it's an exam question, students. Yeah, alcoholic purchased 750 ml bottle. He consumed 10% of the bottle, refilled it with water. He consumed 20% of the bottle, refilled it with water. Third day, 30% of the bottle, refilled with water. And so you should be able to realize after reading it once. So every day he's kind of 10%, 20%, 30%, and such that one day he consumed the complete bottle. What is that complete bottle? It's nothing but 100%. And hereafter, refilling it with water doesn't solve any purpose, because there's only water now. So how many liters of alcohol did he drink across all the days? How many liters of water did he drink? Alcohol is a very easy question. Question number 1 is a very simple question. Think about that. Whenever you have a system of replacing and adding, going out, adding, think water is coming in, water is coming in. Alcohol is not coming in. Does that give you a hint? Yeah, alcohol is never being added to that. Yeah, so that is what. Yeah, so the first one is more like a puzzle type of a question. Alcohol is never added, students. So the alcohol that you would have drunk is going to be 750 ml itself, right? All the alcohol, nothing is added. Now for water. Water is a little difficult, yeah. Many different ways. This, in fact, you should not look at it as a mixture question at all. Anyone who is doing replacement, removal, and so on, alcohol percentage, don't do that. Yeah, good, Siddhant. That is one way. थोड़ा सा अलग अलग आंसर आ रहे हैं क्यों? Let's see. If I subtract 750 from 4,000, I'll get 3,250. Hey, all answers I've got different. Pratmesh is different. Siddhant is different. Shubham, Parmeet is different. Yeah. ठीक है, आराम से एक बार चेक करो. So, Shanmukhi, change your approach. Yeah, if you take time that you usually don't take time. So if you're stuck in a way now, just dump that way and restart. You know, again, obviously I don't know how you study and all at a distance, but I'll just say this. Students are very quick. Yeah, those who are very quick. If you get stuck in a way, don't proceed in that way, because you know it will keep eating your mind. What is wrong? What is wrong? So just erase that and start a fresh way. So different ways, think on the lines of what I said. Here alcohol is never added. Now at start there is no water. At start there is no water in the bottle. Right? So where does water come? All the water, what shall I say, drank, or water consumed. Yeah, that's a better part. All the water that is consumed is nothing but equal to the water that is added. Think this way also. It's therefore I said it is not probably a mixture question. Water that is added, and what is the water added? Oh, on first day you add 10% of the bottle. 10% of the bottle. Second day, so new thought, students. Second day you add 10% of the bottle. Third day you add 30%. Now someone might go ahead and end it where, and someone might end it differently. Think about it yourself. I will on the second last day I'll add 90% of the bottle. 90% of the bottle is consumed, and that is replaced with water. And on the last day I'll not do anything. So I can even stop over here. So if I do this summation business, what's the summation business? 9 is 45. 9 is 45? Yeah, 9 is 45. So 450%, and 450% of 750 is nothing but 4.5. What is that going to be? Let's see. 75 into 4, 300. 300 and 37.5. Yeah. So I get that this will be the answer. Let me confirm once again. The 5, 2, 35, 55. Yes, 3375. So day one कितना कंज्यूम किया उसने बॉटल का? चलो बॉटल का कितना कंज्यूम किया? 10%. ठीक है, तो वाटर कितना ऐड किया? वाटर एडेड 10%. राइट. डे 2 पे 20% कंज्यूम किया, 20% वाटर ऐड करेगा. राइट शुभम? चलो हाईलाइटेड. ओके, 80% ऑफ द वाटर कंज्यूम किया, 80% ऐड कर दिया. 90% of the bottle consume किया, 90% add किया, and then this day he consumes 100% of the bottle. He consumes 100% of the bottle. If you actually look at it, the story stops here. Even if you add water, now bottle is over, it's empty. So if you add water, the next day he's not having, because there's nothing in it. That means as in it's just water. One day he consumed the complete bottle. Okay, Shubham? It's not very difficult. There are different ways of doing it. Okay, there are different ways of doing it. It is not just this way, students. One might also say, yeah, and then there are different ways. So let me just address one way to you. Can you tell me what is the total liters consumed daily? Total liters, and just work on liters. Now, and you'll also understand why it's good to work in percentage. Total liters consumed on days. So first day, any thoughts? First day. No, consumed 75. Next day 20%. The next day 72, 25. Did you get this? So 10%, 20% chalega na? Okay. 75 into 3. So go ahead now, Shubham. In this case, I'm talking about consuming every day. So till what will you go? What is the last day consumed? Yeah, you are looking at consumed. Last day consumed 750. So you will take the 75 into 10. Now, so tell me the total consumed. So is this the total consumed? Is it 75 into 55? Okay, 75 into 55, 5 5 are 25, 2, 35 and 40, 60, 62, 6, 35. Okay, 4125. These many liters he has consumed. Okay, out of which 750 was water, alcohol. 750 was alcohol. Okay, so if you subtract that, that's going to be 740 minus 7, 3, this much water. So, okay, how could you do that, Shivam? Yeah. So this is the total liters consumed, right? So you have alcohol over there. The question is water, right? And remember now, last day here, this is a consumed part, but then he is not adding anything here. That's the end of it. He would have added the previous day. He would have added previous day, whatever he did, 75 into 9, and he would have added 75 into 9. That is 90%, but now he's not adding. Okay, so good enough. Okay, yeah, you could have added that extra 100% and then again okay, okay, Siddharth, okay, 2 बार फिर subtract करना है आपको. Alcohol as well as the last addition. Okay, so here to I guess that's the end of it. This replacing questions that are on the groups, there are quite a few that get shared, students. So in workshops, I'll manage them. I don't want to, generally extend the class. You also have a DI workshop today. So be rest assured, people start studying at different times of, so there are some who are very well versed. There are some who are just picking up the steps. So just pick up the steps. As far as more tougher questions and so on, I will come ahead and I will do workshops, just like Ajay is doing workshops. I will do, but I typically do that during exam periods. So you have a lot of time, October, November, you are all going to be very tensed. What do I do in October, November? Everything is done and so on. So that is the time that I'll keep doing these practice, more varied things, right? So don't worry on that part, right? So that's it.